No chat. No more. No more. Not today. We did more yesterday. We did more the day before. I feel like there was a certain time we even did the mole, but I'm not sure if that was real. I might have just jumped that one. No more today.
Said Razor 1 feels bad, man.
We'll do mole after this experiment is complete.
K said mole.
Which probably tomorrow's stream or day after. I don't know. I feel like I've done a lot of oil rigging, so I wanted to do something else. I was like, you know, I've messed with AI before, and I got one working. No more. No more. Nuh-uh. Nuh-uh. Maybe I'll put up a picture of a mole just to keep you happy. But I've messed with AI before. The one I was messing with, I was feeding it the He-Man transcripts, which I mean, I had like 2 different routes I took with it. But let me get up my sniffing tool so I can draw you a diagram.
K said Ed choose Riot SMH.
Wow, okay, I see. Where's my desktop? There it is. So, what we had, I'll probably have to do this in Creator, but yeah, we definitely need Creator. Creator.
Helter _ said British Indian Ocean Territory.
Go
British
away.
Indian Ocean Territory. British Indian Ocean Territory. British Indian Ocean Territory.
I see you, Helter. Evil. Evil. So, I have messed with AI before, but the issue I had before is the setup I was using. It either gave bad outputs, which I didn't like, or it gave infinite outputs, which also wasn't a particularly good outcome. It's like, I mean, nah, it wasn't like comprehensible yet, but it was getting the sentence structure right.
Said all I did with Ari is make a Ari chatbot of myself.
You made a chatbot of yourself. I'm trying to do the back end of AI, which I mean, as we are basically gonna try to make a chatbot. That's pretty much what we're doing, but I'm trying to do the whole the background process. So this is what I did earlier, just testing. I'll walk you through it in a second. We want to swap these. So what I did on attempt 1, which I can probably get up for you guys. Let me check what is on my desktop, because it might have new legal documents on it. Startopia. That is a resume. I probably shouldn't have that. Put that into the folder. Right, let's open up the first attempt we had, which you guys aren't gonna know anything about, which is why I'm showing you. There's lots and lots of code, and it almost worked. Almost. I don't think this actually has any good data to load into it. I mean, it might have something, but I'm pretty sure I like tried to fix it, because okay, it's up now. Here we go. Okay, so chat. This one was my very first attempt at doing, well, not the very first attempt, but like the first like proper go at it. I messed around a little bit in trying to do it within Unity, but that was kind of a, like, you really don't want the entirety of Unity walking down the whole project. So I moved from C# in Unity to just C++ by itself. I was going to try GPU processing, but for now we are just doing the CPU, which is slower but a lot easier. And we just want to get it working. It doesn't have to be too fast. The easiest comparison to this would be Neurosama, who is an actual like AI who's streaming and such. She runs on Python. I believe C++, was it like 20 times faster than Python. Assuming you're doing it correctly, which, whether I'm actually going to be able to do that is questionable. And then, I did see that Vida was using the CUDA backend, which is NVIDIA's GPU, meaning you can then send okay, hold on. Yeah, you got two different ways to process stuff. There's a couple different ways, but there's two main ones. You got the CPU, which is like, it's like, I think I'm running like an 8-core at the moment, so it's like 8 big cores, and just got a whole load like that. And these are like very general purpose. They're very powerful, but there's only 8 of them. So, I mean, they can do pretty much everything. Like, everything your CPU does happens with these cores. They're very strong cores, but what the GPU has is, instead of like 8 small ones, it has literally tens of thousands, maybe even hundreds. They're just like very, very small, weak cores. So they are weak, but there are many, as opposed to the few CPU cores. And with the AI stuff, it is very much favouring the GPU process. I think doing it on GPU comes out something like 200 times faster, something like that. So if we did switch to the GPU processing, that would be pretty neat, but of course GPU is a lot more difficult to work with. As I said, the CPU cores are very general purpose and can do pretty much anything. I was going to show that, just because I'm going to be curious. So, if you're writing code for the GPU, it has to be very simple and specialized, which is something I don't want to have to figure out as well as everything else. So, the standard way you do an AI is you have nodes. You have your input nodes, and then they call these ones the hidden nodes. We'll just do like 3 layers of hidden. And then, actually no, we'll do 2. And then from there we have the output nodes. You have one set of inputs, one set of outputs, but the hidden layer can be as many layers as you want. The more layers you have, the more processing you need, but the more intelligent the AI can become. So, input nodes is your input. So, every one of these nodes will connect to another node, like such. So, if this node activates some power, then it will give a little bit of signal to both of these. And depending on how it's set up, that might be enough to activate them, and then they will then fire off to the next nodes. But let's assume it isn't. So we're also going to have this node fire, and this one's connected to like that one, and that one, let's say. They can connect to like any of the ones on the next row. So then that would be like enough to fire this one, let's say. And then this one would be like connected to like that one, and then that one fires because that's also like from there, whatever. And then you have the output, and then this actually controls what the AI will output as a response. And so, I'm not entirely sure how it works, but somewhere in this process, by mapping together a whole load of really simple connections, you can get really complex behavior. I don't think we actually know, as a simple term, just how to explain how it does this. But it's literally just this. You send signals across, and that activates that. So that's what we are going to be doing. However, on my first attempt at this, I decided I want to get a little bit funky with it, which didn't go too well. So what I had for my first attempt was I had all of my inputs and all of my middle processing ones, and all of my outputs just interconnected. So any node could connect to anything else, and that would all activate like that, which turns out has a couple of issues. Again, I don't think the last test I did actually will come to anything, but the issue I had was, oh, that's the wrong one. Either have to moderate how they interact so much to the point where it can't actually form proper bonds and won't actually do intelligent stuff, or I do let it behave randomly and just do every connection, which did actually work. It wasn't making comprehensible sentences yet, but it was doing successful sentence structure. So it was doing like grammar correctly. It was doing like full stops and like sentence lengths and stuff. It was doing like paragraphs. That did actually look good considering like how much data I fed it. Like I gave it like 5 He-Man episode scriptures, and it was getting sentence structure from that, so it was working. But again, the issue I had was because I chose this really weird structure which doesn't really work, I had to either moderate it so much that it stopped working, or I just let it run wild, and then I got an infinite amount of good stuff, but just never ending, so it would run until it crashed with just one prompt. So we're gonna be running this one today, and I'm tempted to try to bolt something like this on the side, just like to see if we can do like the behavior of this would like determine like, I don't want to say like personality, but like give weird quirks to that. So I want to try it at some point, but that's like a really dumb idea. So we're not going to do that. So this is the first attempt. What we were doing was we made a neuron a class, and we gave that a whole load of variables. So it linked to other neurons with their weight. It had words, which there's probably better ways of doing it. And then these 4 were from me trying to forcibly make it more intelligent without like actually training it properly. Because again, I ran into the issue where it would either work correctly but make an infinite output, or I'd have to moderate it. So earlier on it was doing the infinite but good, and this current version is doing the limited, where it does kinda work but not anywhere near what you want. So you've got stuff for linking neurons, got stuff for firing neurons. I don't even know what this is. It's been like a year since I last looked at this. That's getting the weight for every neuron. It's then adding weight. What? I don't know what I was doing there. This is relevant word stuff. Again, that was me trying to force it to be better without letting it do its own thing, which of course didn't work. So that was all bad code. We're doing random number generation. That's not good. This one is good. We're gonna need this. This is saving data, which I don't actually know where that is. I might be in the repo, which I'm not sure if I still have that just on easy access. Yes we do. That is a bad save file. That is terrible. Have a look at the old ones. So the data I was both taking and giving to the AI was being done with a text file, which, I mean, this looks like carnage, and it kind of is. It's not even responding. I hope you're keeping up with this. If you're not, don't worry about it because you don't need to know this. This is just me faffing around. There's no actual point to me showing you this, but I find it interesting anyway. So, we had
Venus_K said background sounds.
background sounds. Okay, that's fine. So we had like 3,000 neurons here. What these were doing were, all the ones here are the weight of the link, and the number is the ID of the neuron it was connecting to. So you'll notice we've not got any numbers above the 2,000, whatever it was. And these are all just the links, which, with this level of data, it was making successful outputs. And these are the words. This is where it does words. So you'll see we got Man of Arms from He-Man. Got Hoover. We got a tree apparently. Look at that. We got a tree. I can't zoom in, but that one right there. That one says tree. It's even capitalized. God, this is. Why is this struggling to load? It shouldn't be. Why is the scroll bar going up? It looks like it's making more of this, but it really shouldn't. They're just trying to load everything.
Dnet_K said tree best.
Tree is pretty good. Why is this struggling to load? And nothing's interacting with this. So I think Notepad is just dying. But we don't care about that. Oh, okay, we can zoom in apparently. That's what it was struggling with. We got He-Man, got Fire, Falcon, Low, Man-E apparently. Wow.
Helter_Reese said Ari bad, Mole's good.
AI bad, Mole's good. I'm not getting a Mole on stream. He can't make me. I would never.
Dnet_K said true.
You guys are kind of quiet. Why are you guys so quiet? What setting are you on? On 40%. I'll put you up to like 70. Volume.
Incredible Ed said volume.
Alright, that should be fine. I mean, I've probably just like turned down the system sound, but turned up the BGM, which I'll probably skip that. Yeah, okay. Anyway, so that was the previous attempt, which was kind of ass, but we're going to be stealing a lot from it. We'll probably steal lots of the load
said,
data.
Dnet, did you see that Ree has a real Discord now?
I haven't seen that one either. I want to link to that. Alter, put it in the Discord. I want that. And for this I also had a whole load of like manual ones. But and yeah, it's trying to do relevance, which again we really don't care about. But so this one is the new attempt, which is a lot more bare bones at the moment. So what we have here is we have on neuron. We are actually organizing things into layers this time. So we've got a list of neurons, which does make sense.
Said Yo Nixie gave it to her at the end of the stream yesterday.
Nixie gave... Well, what's going on? I don't know who Nixie is. I do not know. I don't keep up with this stuff. But I do want to link to that Discord.
Dnet_K said right when I left Razor 1 cry.
So we have a list of a list, but it makes sense. Because we've got this system here, so I'll pull this over. That's got no things. There we go. So what our list is we have all of these groups as their own lists. So those are lists. And then we have a list of each one of these. So, like that. So this is big lists, these are little lists, which is why you have a list of lists.
_K said thank you.
I might regret doing it like that, but it might be fine. We'll see.
_Helter_Rees said okay, I sent you the invite to the server.
I'm gonna go have a look at that. Helter has sent me a DM. I have been invited. I'll double check. I'm not on desktop. I am not on desktop. Hey, I have joined Ray's server. Very cool. We got rules, we got entrance, about, comms, streaming, schedule. They don't have a general. Huh. How am I supposed to bully people without a general? What is this tomfoolery? There's not like rule. Oh, there are rules, but there's nothing to actually react to.
Said go to rules SMH.
Oh wait. No, I got it. Now I have the general. I thought because only on one is not actually the thing, but apparently it is. Hey, I am in the server. I shouldn't be doing this for certain streaming, but
said no bullying allowed. It will look bad on me.
No, I'll bully. I gotta make children cry, you know? Okay. I'll do a wave to them, and then I will go back to streaming.
Said, degree.
Hello, Jar Jar. I just found out that Ray has a server. And so I am now in that server, which I shouldn't be doing live, but, you know.
Gene Drake 10 said I heard we bullying orphans.
We are bullying orphans. So true. Anyway, back to code. So, where are we? So in this iteration, we have got a general structure for a neuron. We are doing layers as they are, with an integer.
Degree.
We have an ID. We have the activation energy, so we're just going to need multiple neurons to fire in order to actually activate, which I'll have to figure out how to do multiple words later. But for now, we'll just do one word. Like what we're going to have is, if you remove all that stuff, we're going to output. Now, what we need to do is we need to form sentences based on what we had before, which is going to be quite awkward. So we need the external input, and then it'll take all the words of that, and it will pass them into here across all of these, and then that will fire up a bunch of the neurons, and they'll fire up the next neurons, and so forth. However, that's probably going to make one word at the end, or I mean, you could do multiple. Like if you have multiple ending ones fire, then you would get multiple words, but you wouldn't have a word order, which is kind of awkward. So what we're probably going to have to do is we're going to have to take that output and pass it back to the input and get something new from that. What I haven't considered is if multiple outputs fire, which what we'll probably just do is we'll do all the stages up to it as normal, and then we'll just find out which one has the highest weight, and then we'll choose our output from that. Highest weight, there's a T in there somewhere, equals output. There you go. So that will give us one word, but I don't know how to continue from that, because if we then pass our output back to the input, if you just pass one word, then that would fire up one neuron, which might not be enough to then activate the rest. We could save previous activations, but that seems I mean, it could work. And if we are sending the entire output rather than just the most recent word, then that could then cause an exponential output, which is what the issue I had last time was. So we can't have all of that, which is going to be an issue. So I need to figure out how to do that. I know how to hook the neurons up and do all that, but I don't know how to then both have the system produce a good output whilst also not making it exponential. Because again, like, probably not to mention, for the input neurons, I'm probably going to have one neuron for every word, and you input an entire sentence, and then it will then fire a whole load of neurons based on that. Do like these, and then those pass their signal onwards, kind of. So we'll pass the entire sentence in for the input. We could lower
K Sydneyan sounds like
Nyon. Okay, I'm trying to do Japanese in my TTS again. It's still on the to-do list to get a new TTS. We can actually do funny stuff with it. But we'll do that eventually. What we could do is we could have the neurons remember their weight and then just like half it each time, which we'd have to be careful to not make a an infinite output. It's like if we clear out some of the last text. What did you said? He said Nyon is an extra N. I'm guessing, well, that one's Ni. I'm guessing that's Yo. And that one's just an N. I have no idea what those two characters are. That one's a Re, I believe. I'm not translating that. But like, if we save half the input every time, we get the second half of. Like, this won't be enough to then activate the next ones, but since we're only passing one word back, like, the added weight to the system isn't going to be much, so it will continuously drop weight overall with a recursive setup. So we'll always pass one unit of weight back. If the external sentence is like 5 words long, then that equals 5 weight. And then that would go like 5 in half down to 2.5, add 1, so then 3.5, half that to like 1.75, and then just like keep on going down until it stops activating, which, I mean, I don't really know how I'm gonna do it. This is, I've got it like almost working before, but I've not done a full one, so it's like, we'll figure it out. Anyway, so to the code. So we are saving the layer, the ID, how much activation energy it has, which is the weight being passed to it. So this would be like, I don't know, like 2 units of weight from this big blob and like 1 unit of weight there. We have the linked neurons and the linked weights. That is not that. That is these blue lines getting across and how likely they are to activate. And if they do activate, they will then send their signal value as to the activation energy of the next neuron. The int for the function is just for if I want to try giving it the option to do subtraction or stuff like that, which we're not going to use yet. In fact, I should just like comment that out for now. And string for the word. That's only needed for, that's still not the right one. That's only needed for the output neurons. Because those are the only ones that will actually make a word. So I could just have, that's still not the right one. I could just have a different neuron class for the outputs, but for the sake of one variable, it's like, I'll just leave it as is for now. This is code I stole directly from the previous attempt. This just links to any other neuron you give it. Which, yeah. I mean, that doesn't entirely conform to this, to the setup we're using here, because this doesn't check for what layer it is going across the horizontal layers. Each one of these is a layer. So that isn't checking for that, so theoretically we could then connect like this neuron over to here, which isn't very good. That might cause issues later, but we'll fix that later on. That's on the to-do list. If we're saving just the ID, then we should, like, if you like linked it to there and then saved and loaded it, it then should load going that way, but it depends on how I code it. So we'll see. So that's the linking. We have the firing. So for this, I actually did this wrong earlier. That's kind of annoying. So what I have done here is I'm going through the list of weights, and I am then adding that weight to the activation energy of the neuron it's checking. However, that's not what I want to do. I want to use the weight to determine whether it should be activated based on a chance, and then we will add the signal. So we are adding the signal, which is literally just I'll copy this across for a second. I'll probably need that in a second. So we will send the signal to the next one we are connecting to. How do you spell signal? Like that? Yeah, like that. Okay, we now need a random number generator, which... Do we need another library to do that easily? I don't think so. I did do it on the previous one, so I'll just see what I used, because it has been like half a year since I used Steve++. So this is our option. So do chosen weight as a random integer. So
Helter_is said random number generators aren't truly random.
yeah, but they're random enough for our application. And we are going to be responding to inputs, so unless you give it the exact same input with no changes in its data, then it will be functionally random, even though it's not true random. It'll be good enough. Good enough. This is taking the total weight. We don't care about that. We want the weight from the link assignment.
Helter_is said molehead.
Molehead. Shootle mole pop. Shootle mole pop.
Dnet_k said SMK.
You don't even know what I'm talking about, Dnet. You can't shake your head at me. Disgraceful.
Helter_is said SMH molehead.
You weird people.
Dnet_k said SMMH.
Yeah, maybe I should get Turmoil up. That's probably more interesting, but I was doing this anyway, so I want to do this, even though it's probably not going to be as entertaining. But I'm doing this for fun, not just for like numbers and stuff, you know? Alright, so we're finding the random number generator. I'm That's still not getting what we want. So this weight isn't what we want. We want a maximum weight for like this would generate a number between 0 to, let's say, 100. We'll probably change it later. We'll give it a variable, so we'll do like int max weight. I need to change that later. I'm going to set that to 100. So it will generate a value between 0 and max weight, which is 100. And then
Mr. Cheddar said,
hello Cheddar. You are saying weird Japanese characters. We are doing coding today. It's nothing particularly crazy, but I wanted to do it anyways, so you guys have to sit around and watch this. You have no choice. So, that's generating a number between 0 and max weight if
DNet_K said,
if the weight of the
Mr.
connection is greater than the weight we just generated.
Helter_Is said he wouldn't even give us moles SMMH.
I'll give you moles tomorrow. We've done moles the last 2 days.
Said SMMH.
I need to give you guys something else to do, you know? Well, something for me to do. Like we can't just play Turmoil like 3 days in a row. We'll do Turmoil tomorrow.
Gene Drake 10 said.
Line.
Helter_Is said moles today.
We could technically do a little bit of moleage. We could, but I wanted to do something different. God, I wonder what that sounds like for you guys. That's me taking a drink from my very broken water bottle. Okay. So if the wait, do you want that to be greater or less than? Like this we'll move all this over. So this is taking a number between 0 and 100. And it is assigning a random value. Let's put it like there, for example.
Gene Drake 10 said Guacamole.
And we want it so that the greater our weight to the thing, the more likely it is to be picked. So let's say really high weight. So that means we want, if this weight is lower than this weight, then it activates. This one is the weight of the connection, which is linked weights iterator, and we want that to be greater than the other one. So this is fine as is. So based randomly on the weight, it will then decide whether to add the signal strength of this one to the activation energy of the other one.
Helter_Is said I'm going to make a propaganda poster for moles against Ed. 420 Mr. Cheddar said SM.
Why do you guys love moles so much? Like, do you guys just love everything that I hate? Like, the moment I say I don't like something, you will decide that you're gonna make like artwork for it and like posters and do like whole copy pastes for it. Like, why do you love the things I hate? What is wrong with you people?
DNet_K said you hate what we love.
I do. So one option we do have is instead of sending the signal,
Helter_Is said yeah.
We can send the activation energy, and that will then do cumulative stuff based on what we had
420
before.
Mr. Cheddar said we like taco beans.
Now, I know you're lying about that one, because no one likes taco beans. So, if you guys think you like taco beans, you're clearly just lying. Just because you know I don't like them. There's no other reason.
Said chat reflects the streamer. Dnet_K said your dad does.
Yeah, but my dad's weird.
420 Mr. Cheddar said I really eat them.
You're weird, Mr. Cheddar. Why would you ever like taco beans? What is wrong with you just as a person? Well, like, who dropped you when you were a baby? Where did it all go wrong? That was the wrong one. You want... Wait, do you want this one? We've got more stuff on there. I haven't even looked at that stuff yet. So the option we have is to send
420 Mr. Cheddar said they are the true beans.
Is to send the activation energy. Because then if you have this, where this one has a massive activation energy, and this one has only a little activation energy, then let's say they both connect directly to the next one. Then when this one activates, it then also puts in a very small amount here, but this one puts in a massive amount. That's actually a really terrible idea, because then this would then like always activate if this one activated. And that would then always activate the next ones, which is a bad idea. We could do it based on the layers, so as you go you need a stronger and stronger signal strength. That is an option, so like you need like 1 unit here, 2 unit here, 3 unit here, and of course 4 on that one. Although that one's just highest win, so we'll leave that. So this would then have it send like so if this one is 2, then that would then send 2-way to this one, so then this would activate but this wouldn't. But if this line was then connected with a signal strength of 1, ignoring the fact that that wouldn't activate with a signal strength of 1, then that would get a signal strength of 3 here, which then would activate it, and carry a signal strength of 3 over to these 2, plus whatever that one was, which we haven't actually checked. That is an option. I don't know if that would work, though.
420 Mr. Cheddar said disgraceful.
Disgraceful?
Helter_is said by the way Ed, taco beans don't exist.
You are lying, Helter. You are lying. That is misinformation. You are spreading misinformation inside of my chat. I do not believe you. There are taco beans everywhere. Have you ever been to Mexico? They love beans over there. So,
20 Mr. Cheddar said don't tell him that.
I'll add that as a comment that we could do the activation energy instead. And then just do a note here as an alternative. So we can mess with that later. That might help it focus on specific outputs. But that might make things more complicated, which we really don't need, because that's been the bane of my previous attempts. So I don't need that. So that should be that function fixed. It takes every neuron it is connected to. It chooses a random weight. If the weight it has chosen is greater than that weight it chose, then it sends its signal to that next one. And then it checks, then it moves over to the next one, and then does it again, and checks there. Okay, so that should be fine. Alright, and then this is our input. I stole this from my previous attempt, which is why it looks a little bit funky. This is clearing our input, doing a new line. That's just to make it tidy. And that's entirely visual, just so it doesn't like do the output and then you like write directly onto the end of the output, because that's no good. So it clears the input, does a new line, that's fine. It then makes a new string called getInput. and then gets the entire input of what the user has typed into the command prompt, which I can feed some other code and stuff into that if I want, but for now we're just using the command prompt. It is then making a string stream, which then turns a long sentence into individual words you can take from. We are then putting our input we got, which is one massive string, into this string stream so we can split it up. I might be able to do it just like sticking this into here. That might be an option. Although apparently it isn't, so there's reasons why I did it like this last time, so I will assume that this is a good way of doing it, which it might not be. Then makes a new string for the input, and it then takes the first input from the string stream, which is the entire input split into individual words. So it takes that first word from that list, and then it does this stuff with it, which what have I done here? This is taking the input and putting it into the total? What? And then this one is taking the total input and taking a word from it. I'm pretty sure this is supposed to be like that. I'm pretty sure. We'll test it. We'll just see whether it crashes, pretty much. But I really shouldn't have both of those around. I also don't need to do it like that either. It does crash in line 151. We don't have any code there, so that's not how that happens. Oh yeah, we also don't actually have any data in this, which is going to cause issues. We're doing that exact bit of code, like right here, so
420 Mr. Cheddar said DNet could you stream?
I don't
To see on me as a viewer, of course.
I don't think we actually won that line. I might be wrong, but I'm pretty sure. Am I boring you, Cheddar? And it's not the most exciting, but we've done like drilling for oil for the last like 2 days. So I wanted to do something else. So that might be important, it might not be. And this, it takes a word and then checks through every single neuron, which is unnecessary. And then checks if the word of that neuron is the same as the word we're checking against. If it is, it gives it massively high activation energy just to make sure it activates, and then it goes to the next input. So that is that. I think what we're going to do is going to work on saving and loading data, which is going to be a bit of an ass. So I did like a little bit of planning on this earlier. We got our structure. We're going to do. Right, let's get a notepad up. Notepad. Just to like plan this out. So we have the quantity of layers. Let's say 3. Then do the neuron count for all layers. So like we've got 3 layers, and that would be 3 layers of 9, 8, and then 7. So we can just read that. It's like we know how long this is going to be based on how long this is.
Wrong time.
Wrong time? Wrong time. Wrong time, yes. So that's the quantity of layers, and then we need the neuron count for every layer. Wait. No, that's the neuron count. So this is the neuron count. And then we need the neuron So from here we can then determine how many neurons we have. And starting from the very beginning of this, we will then start doing our neuron data, which is we can do the layer and ID based on this. We don't need to save it. We just need the link ID and weight. So if the first neuron, the ID I'm doing them as, because I can't save the actual memory references.
DNet_K said.
What did Danette said? Neuron. Okay. So the way that I'm doing the IDs is I'm labeling them as 1, 2, 3. This one's already labeled, which is quite helpful. And so we can do it, so saving it, we can say that for our first neuron, it connects to a neuron with an ID of 2 with a weight of, say, 20. And that is just all we need for that. We just need the ID number and we need the weight.
Helter_is said OK Ed pick 1, RAM or REM.
RAM or RAM? I would say RAM. Because Bluehair's kind of neat. I hear my parents, but they're not in here, so it's okay. They have a little handheld vacuum cleaner thing. But I think RAM better. Wrong choice? Okay, wow. You would have said that regardless of what I choose, but sure. I've also never actually seen the anime with RAM and RAM in. Maybe we'll watch it at some point. Anyway, so we need to do our save data. I don't remember how to do this, so we'll steal it from my other code. We're going to do an output stream. I don't remember what the F is. So an output stream called save file, and we are going to open a file called, that's the load. We're going to open a file called savefile.txt, very simple. And then from there, we literally just start writing to it. Okay, that's quite easy. So, we need to load each layer, which is... so this is where I'm going to start regretting doing a list of a list, because that gets to be a bit of a hassle. So we need to do... I believe I just call it neurons. Yeah, neurons.size, which is that's not what I called it. I did it with an S. I might have auto corrected it, or it might have been my mistake. So that is the number of layers we have. And do a space, so it's the first number. So we got the 3 here. I'll zoom in a little bit. So we got the 3 here. If we just went to straight one, it would then do the 9 directly after it, which of course then reads as 39, which is no good. So we do the space, and then we have to do the amount of neurons for each, which is going to be save file. We're outputting to save file. We're outputting so we need to iterate through the list of lists. So we are going to do a list. Hold on, I need to think about this. So to do an iterator, we do colon. I have one somewhere in here, I remember. Yeah, so here's an iterator we did earlier. So to do an iterator, you do the format for making the thing you want, and then just put colon iterator at the end. You name it, and then you tell it the list you wanted to iterate on and where you want it to start. So we want to iterate through our list of
Helter_is said, what is your searching algorithm
lists.
going to be?
My searching algorithm, hopes and dreams. No, we for saving and loading, we are just doing it in a in plain text, just in a specific format, and we'll remember that. For actually finding the neuron within the data, the current setup we have, which is absolutely terrible, and I know why you're asking it, because again, it is terrible and I can improve it a lot, is to just do actually, I don't think we even have it on here. Do I have it? Got define neurons. Okay, we don't actually have it yet, but we do have a list which can separate into each individual layer. Once we get to the layer, so we have a list of each of these, so we can do this separately. And what we're going to do is we are going to progressively iterate through literally every single neuron. I'm just going to go, has this fired?
Helter_is said you should use BOGO sort.
No, I know BOGO sort. So if it has fired, we do our inputs or outputs. If it hasn't, we just leave it and we go on to the next one. So we're checking every single neuron once. And these will all have a direct memory reference to each one it is linked to, which is probably worse than just storing the ID, but it means you don't actually have to calculate what we're searching for each time. The music has stopped, I'm aware of that. That is probably not free. This is what I had before. So, I don't think we actually have to search everything, because we are checking literally every single neuron once.
Helter_is said, okay, what about Stalin sort?
We'd lose half our data if we did Stalin sort. For those who don't know Stalin sort is you have a list of unsorted items. We'll do 4 items. We'll call them 1, 4, 3, 2. Sure. So we'll check the first one and it'll go, starting at 1, that's the lowest number, that is A-OK. Yeah, it's trying to put these in order of the highest value. So lowest at this side, highest on this side. And then look at the 4 and it'll go, that is higher than 1, so that is good. We'll just leave it as is. And then check the 3 and it goes, 3 is less than 4. That doesn't conform with what we're doing, so we literally just delete it. That's gone. And check the 2, it does the same. It's not how we want it to be, so just delete it. And so what you end up with is a sorted list where every item you had in it, or every item you have left in it, is correctly sorted. It's just like half the size as it was originally, which is kind of funny, but not what we're doing here. But yeah, again, I think we literally just don't need a search algorithm, because we have direct links and we're doing every single neuron, so that should be fine. We have errors down here apparently. We're saving it. Okay, so we need to get the amount of neurons for each layer. So we do list of a neuron, I believe. I think I just did like that. Let's check if that's the same up here. List neuron, yep. We're gonna call it neuron iterator. and lowercase at the start because that's how I've done everything else. And the list we are starting on is neurons, which is capitalized for some reason. That's terrible. So that is our iterator, and that will go through each list of neurons contained within the list of neurons, which is confusing to say. So we then print the neuron. In taking the neuron iterator, we are dereferencing it, so we're saying what it's actually pointing to, and then from that we are then taking the size of that. Yeah. So this is currently checking the very beginning, which is the first list of neurons, and it is then saving the size of that list. And we need to do that for every single list of neurons within the greater list, so we'll do a for loop. So for list of neurons, and can also just take neurons.size. We could just take neurons.size, or actually we might not even need the iterator if we do it at the for loop here. I think this would probably be faster because then we don't need the iterator. So we'll call this like neuron list check. So for a list of neurons, which we're calling neuron list check, in the list of neurons, which is called neurons with a capital N for some reason, and an S. From that we are taking the save file. We don't need this anymore. And we are taking the neuron list check, which is the list, and we are printing the size, and we need to print a space so they're not all just together. So that should be done. So we're doing the amount of lists we have, we're doing the size of each list. At this point I think we have to then generate the neurons, and then we'll connect the neurons. If we're making the neurons, we probably ought to figure out if they need anything. So layer we assign on the based on when we're loading it. ID we can load based on when we're loading it, or we can save based on when. Words. Like we need the layer, we need the ID because it's just something we already have. I'm getting confused between saving and loading now. In fact, yeah, I am getting confused about that. So we will save then the neuron data, which will be, we don't need the ID, we don't need the layer. We don't need the activation energy because that is always starting at 0. We do need the linked neurons, and we do need the linked the weights of those links. We probably need signal, we probably need the word. I'm gonna need a marker for when this list ends. We'll copy this down just so I can see what it's like. So this is all of our data, which we need to save. So we don't care about that one. Oh, I mean, we could use it. We could. Good. So... I need to decide whether to save all of the links and then all of the weights, or to save one link, one weight, one link, one weight. I'm pretty sure we can do it all of the links, all of the weights, which isn't going to look as clean in the data. You can see what we had before, if it loads up, is we had the... I shouldn't have zoomed in, that's going to take ages. We had the... that's actually not responding. Okay. Well, we'll just have to sit here for a second. How you doing, chat? How you doing? You enjoying the coding stream? I know it's not as exciting as the normal stuff, but again, I wanted to do it anyway, so we're doing it. Tomorrow we're doing more oil drilling. I'll probably work on this. In fact, hold on, tomorrow I've got my my afternoon stream. I didn't even think about that. But I'll probably mostly work on this on my own time off stream. I'm probably to like rest my like talking part of my brain between streams, because like talking and thinking about code are like two very different parts of the brain. So, you know, has Notepad fixed itself? Yes, it has. Okay, very nice, very nice. So, what we have here is we have the number of what it's linking to, and then the weight of that link. So this is linking to...
Gene Drake 10 said code tastes funny.
Code tastes funny? Yeah, it does. So, this is linking to neurons 616 with a weight of 12, and 620 with a weight of 1, and 621 with a weight of 4. So this is a lot more readable, and I can actually edit the save file manually like this, which I think is pretty neat, but it does make the code slightly more complex, which, yeah, is probably fine, but like, you know. Do I want simple code or simple save files? I need to choose one of them, but I don't know like what would be better for us. Yeah, you'll see a -1 here. That's quite significant because, in fact, there's another one there. I was separating my code with, well, -1s in this case. So I have no idea what this section is. That's probably like input neurons maybe. And we have the start of the word, so it's -1 and it's the. And it's got a whole lot of things linking to it, which I don't think we actually care about. And again, this is old data, we don't actually care about that. I don't know whether I want simple code or simple save file. Chat, help me. What do I want? Because it's kind of a pain to change it later, because like if you do training and then you decide to change it, then you have to either make a bit of code to... Actually, it's not that difficult to change, because you change the loading... No, you change the saving code, but not the loading code. So it loads it in the old format and then saves it in the new format. And then you change the loading code to then take the new format, and it loads new format and then saves new format. Okay, you know what? We'll save it as. It would be so much nicer to read. Oh. I'm gonna do the save file way. Easy readability on the save file. That's pretty neat. I can then like manually track what it's doing, you know? So we'll do an we need to take our neurons. So so we're gonna go for this again. So we're taking our list of neurons from the greater list, and then from that new list we are then taking the individual neuron, which we'll call neuron check with a K, not a J. And we'll get the neuron from the list of neurons, which we are getting from the list of neurons. The neuron list check. Okay. So that's now our individual neuron. And we will then save the... we then need to do another for loop from the to get the list of linked neurons from our neuron we are checking. So we'll call that link check in the neuron check, which is the neuron we're looking at. Did I spell that wrong? No, I didn't. That's lying to me. Oh, no, that's not lying to me. I need to get that from the linked neurons list. So from the neuron, we are finding all the linked neurons, and then for each link, we are then saving that to the save file. God, I don't like how complicated this is to say. So we'll then do we need to get the ID of what it's linking to. So we'll do link check. We will dereference and then get the property of the ID, which we can do in one go using the arrow. That is the ID, and then we'll do a list int iterator, which is going to iterate through the list of weights from the neuron. So list iterator, we'll call it weight iterator, and we're getting it from neuron check dot linked weights, which is a list of integers we are iterating through, and we're going from the start of that. So that's our iterator there, and then we will output that information to the save file tool, which is the dereferenced weight iterator. And then we have to advance the iterator. For those who don't know what the iterator is, I will quickly go through it, which I'm probably not going to explain particularly well, but I feel like I ought to explain, because I'm pretty sure most people here aren't going to understand what I'm talking about. So, in C++, we're using the list, which you have to do the include list at the start, because it's not on by default. So, for a list, you have a whole load of variables. 1, 2, 3, and 4. And we'll call this list list A. You see I'm like very imaginative with the naming scheme. So in most code you would be able to do list A and then do like the second value, which would then go through the list, find the second value, They usually start at 0, so this would be the 0th value, this would be the first. It'd actually grab that value. But you usually just do it by saying what part of the list you want to grab. However, C++ doesn't let you do like random access to the list. It doesn't like that, so instead you have to make a thing called an iterator. Now we'll just call it iterator. Iterator. And this has to be the same type as the list. So this is list A will be a list of ints, and the iterator will be an iterator of a list of ints. We're just going to call it iterator. I'm not going to change that. And what we have to do is we have to say that this equals list A dot begin, which is just where list A begins. List A dot begin, which in this case is the very first value, which is this one right here. And what it does is it then just sits here at the start. Like you can imagine the iterator as an actual dot on the list. And we also have the piece of code called advance. And what this does is it advances the iterator through the list. So if we did advance, we have to call the iterator. We have to, like, say we want to advance the iterator by a certain amount. So we'll call advance iterator. I want to iterate it by 2. What it does is it then finds this iterator and it physically goes through the list and finds the next place it needs to be. So 2 ahead takes us from 1 to 3, and that is now where it is. And what the iterator is it's literally just a reference. So the iterator is saying that it is referring to the third position of list A, which will have like an actual memory address and all that. So this is a reference. The iterator is referencing the list. Reference. However, you can't just do a reference. You can't say I want, like, we can't do the math equation of like 5, that's an S, but imagine it's a 5. We can't just do 5 plus the memory address of the third position of list A, because that's not actually like meaning anything. That's a memory reference, not a number. We can't add that. So we have to dereference the iterator by putting a star at the front of it, or whatever you call it, like one of these things, you know? Whatever that's called. I can actually check with the TTS. What does the TTS call it?
Incredible Ed said.
Well, very helpful. We have no idea what that is. Okay. So we have to dereference it, and that would then say, I don't want the reference of the third position of this list, I just want the actual value which is in it. Which in this case...
10 said asterisk.
Asterisk. Thank you. Thank you. So in this case that is just 3, and then that would give us, of course, a value of 8. So that is what I'm doing here. We also can like access properties of things, so we could do like list A dot size, and then that gives us the size of list A, of course. That's supposed to be brackets. So if you are both dereferencing something and you're referring to a property of it, which in this case for us is the the ID. Like if you are doing both of those at the same time, I need to create it over here. If you're doing both of those, then what you can do is you can just do a arrow like that. And that will do both of these in one go, which is slightly easier to read. So we'll call this like the dereferenced version of question mark going to ID. This is exactly the same, it's dereferencing, finding the property. So that is what that is. So, and that is why we need iterators, because this is checking every value in the list, but then we've got two lists which we want to work through at the same time. And so whilst this is going through one list, we are doing an iterator which passes through the second list at the same rate. We can always get the values from each of them. Okay, and then saving that data to the save file. That's getting all the links from all of those. What other properties do we want? This is getting the link strings. Okay. So we know the format we're putting it in, so we can just do other stuff now to save us some effort. So we output to the save file at the start of a neuron the neuron's signal strengths, and of course the space. We also want the neurons the word, yeah, with the space. And we do have the function, but we're not using the function yet, so I'm not sure whether I actually want to put that in or not. Like, kind of, I don't know. I might use it later, but for now I think we will leave it. I do have the trick where we can change how it saves data before we change how it loads data. Load an old format, change it, and I output that as a new format to reformat the save file, and then change how it loads it. That should be fine. That's all the neuron data. And then between each neuron we want to put a marker. And then when we are loading this data, we are just gonna say if the input is what symbol do I want to use? I'll do the like vertical line. So if the next piece of data it tries to load is a vertical line, then it knows that that is the end of the neuron. And then the next thing it will then try to load is the next neuron's signal strengths, the word it has associated with it. Then it does the waits for an unknown amount of time, like when it's loading it. Like here we know how long it is, but when we're loading it, we don't know how many links the neuron we're loading has. So we're just going to keep on loading it until we reach a point where we hit this, and then that will mark when we should stop loading. And then that should be it for neuron data. And that covers the links too, we don't need that. I'll put this comment next to this one. I've also somehow managed to get sunburnt recently. I sat outside for like half an hour, and it's been so long since I've seen sunlight. It's like sitting in the sun for half an hour was genuinely long enough for me to like get a sunburn on my hand, which is quite a bad sign, you know? Maybe I should go outside more. Maybe. Oh well. That should be saving data fine. We don't have any data yet, so we can't actually test it. I mean, I guess we can run the code and see if it crashes. I mean, again, it will crash because it's going to attempt to it's going to try starting up the code, which will then require it to use a neuron, but it doesn't have any neurons, and so it will try and do it, and it will fail, and it won't know what to do because I haven't given any failsafe against that, so it just crashes there. So to fix that, we either actually put in the failsafes, or we just don't, you know. We want to do the when it first boots up, we're gonna do the load data function, which is the one we are about to write. And then we'll do the file neurons. We'll probably manually write a save file just to get it started. That's kind of my aim for what we're doing today. And then the next time I work on this, I need to figure out how to teach it. Like it can, once we get all this done, it'll be able to handle the neurons. It'll be able to save and load the neurons. It'll know how to go through the whole process of taking the input. But I won't actually know how to learn yet. I'm not sure how to handle that, which, you know, I probably ought to know, but yeah, we'll figure that out later. We're probably going to accidentally make an autocomplete rather than a full chatbot, because I'm probably going to end up feeding it data from streams and such, like this one right here. And it will just have a list of every word that's being input, and it will try and make associations from that. I'm not really sure how I'm going to do it, but it should be fully compatible with what we're doing now. So, you know, I'll finish writing this up, and then I need to figure out how to teach it the rest, how to teach itself. Once we've got that, we've basically got a working AI, which is the whole goal of this, which would be really neat, you know? I like to be able to play around with that, you know? It'd be pretty nice. But it takes time. So we'll do the load data now. So I believe this is an IF stream we need, yeah, an if stream. We also have a pointer here for some reason, which I don't know why we're doing that. I also did it in two separate functions for memory handling. So I'm really bad at memory handling. I started in C# where it does all the heavy lifting for you. But C++ isn't so forgiving. So I have to actually figure out the memory stuff at some point. So you know, that might take a while. That's an early version of this project. We don't want that anymore. So we're loading the data. We have our format here. So when we are loading the data, we will take our list of all neurons and we will resize it. Yeah, resize to the information we are about to pull, which is an IF stream, which we're going to call save file. I did do it lowercase before. So input stream of save file, we then need to access that, which I forget how to do. We need to do savefile.open savefile.txt. I will also need to close the save file when we actually save. I forgot about that. I am terrible at handling memory. So we'll do savefile.close at the end of this. Savefile.close. I do also notice we've only got 2 viewers, which is I've kind of expected. I was hoping for that, but you know, I understand why it's low, because this isn't as interesting. So when I do the rest, I'll probably do it off stream, but you know, I wanted to do it anyway, so yeah, maybe I should like actually start scheduling this stuff out, but we'll find out the hard way. But it's like it's an interesting test because yeah, I don't know what you guys like, what I can get away with. Anyway, so the save file has been closed. But opening this save file, do we need to make a stream from that? We don't. Oh, it is over here, okay. So we take the neurons.resize from the output of the input stream, which I think I have to do an extra number just for that. So int tempint equal int. I'll do temp integer. We are passing to that from the input stream. We are getting errors on that, which is concerning. And we're putting that into the resize. Why is this complaining? Type name's not allowed? Because I need to do the save file and not the IF stream. This is complaining. Is it the other way around? I thought it was fine that way. This is save file pointing to the right to the input int. Okay. So I need to do it like that. So I did have it right, just the wrong way around. So that resizes the list of lists to that, and then for I want to do a for loop based on how big neuron cell size is. Been a while since I've done loops in C++. I might genuinely be able to just do the number, but that seems like that feels like it'd be too easy, you know? We'll try it, but like I'm not expecting it to work. So for neurons size, does that work? It does not. We can just do for list of neuron called neuron list. Actually, what did I call it up here? Put it neuron list check. Wait, we're not checking it, so we're not going to do that. So for the neuron list in neurons, we would do a neuron list dot resize to the temporary input we're going to pull from the save file. So save file outputs to the temporary integer. We're then resizing the neuron list to the temp int, and it will then resize all of the lists to the correct size, which, I mean, there's probably a bug somewhere in here, but that should work. So we got that bit that bit loaded, we've got this bit loaded, and now we need the actual neuron data, which is going to be a bit of a pain, so can also slightly compact this if we because we're doing like two exact same loops here. We could take this, put it into here, but we could actually. That wouldn't even be that much trouble. Like what trouble would that cause for us? I don't think that's any trouble. Oh. Okay, maybe we'll try running it like that. Which is a slightly different format from before. So do the neuron data label there. And when we are loading it, we will load the data straight from here. So this will be a while loop. So while temp int doesn't equal. This is why I used -1 before, wasn't it? Yeah, okay. So instead of doing the vertical line, we'll do -1. So as long as the input we are taking isn't -1, we will then load the neuron data. Although we can also just do the size of the temp. Oh. Well, we might not even need the marker. So for neuron in neuron list. Ah. Okay, we don't need the marker at all. We will then load the link ID and then the weight iterator. Actually, we need to do the Oh. Okay, we don't know how many links it has. That's why we need the marker. Okay. So for the neuron, we'll load the signal, which is an integer. So we'll do save file outputs to temp integer. We then the music stopped again. Why could it went to the next song? I'm not supposed to do that. I mean, we probably also change the music at this point. This one says copyright free. I trust it. That's the wrong one again. So we take the temp integer, and we are putting format. Save file outputs to temp integer, and then the neuron dot signal strengths. Yep. Equals the temp integer. And then we'll do a string for the temp string that will handle the input, which is what the word is going to be. Most neurons don't need a word, but it's easier to just have a singular type of neuron and just like have a redundant variable on the ones which don't have a word relevance. So temp string temp string equals
Vibing Gamer Dev said here comes the vibes.
Heyo! Hi!
Vibing Gamer Dev said was sharp.
I am trying to code an AI. I'm not. I mean, I've tried it before.
Vibing Gamer Dev said I'm your 30 follower now.
You're my 30s follower. I get affiliate at 50. I've been keeping track of it. Never as many people because they're demanding moles, and I'm playing the mole game tomorrow. I played it for the last 2 days, but today I want to
Gene
decode.
Drake 10 said hello there.
Hey all. So I did do a working AI before, but I did a really weird structure just to see if it would work, and it did work, but it made infinite output, or I'd have to moderate the output so much it then stopped being able to do anything. So the previous attempt completely failed. That was no good. So I'm using the traditional setup, which I've got a lot of random notes here. So I've had one where it's gotten sentence structure and grammar correct, not the actual word meanings, but it's half the way there. So this one I'm actually doing a proper structure, and hopefully this can get some basic word meaning, but it's I have no idea whether it's gonna work. We're not gonna finish it today. We're gonna finish how it functions and handles data, but not how it learns, which I'll do another time, probably off stream, because the regulars aren't as fond of this one. They demand moles. Anyway, so we are taking the temp string, and we are then setting that to the word of this neuron, which is like such. That is then like this is our neuron. This is the data it has. We can figure out that stuff. This one's always at 0. We've just saved and loaded that stuff. We've saved this stuff but not loaded it. So we need linked neurons and linked weights. So we've got that, and then we need a loop which will go until the input is a -1, because I'm using a -1 as a marker for the end of the links. So as long as temp int doesn't equal -1, we will perpetually iterate through this and load a new link every time. So we do neuron dot linked neurons. We need to get the ID, which is gonna be a little awkward. This also isn't gonna work for this, because then we're not resizing the next layer, like next one of these, until we actually start loading it. So the previous setup I had was better, where we did 2 separate loops like so, which is this. So we are resizing all of our, like, we've got a list of lists of neurons, which is, do I still have it? I might have deleted it. Actually, I think I just did it on this. So all of these vertical columns are lists. I'll do it in pink. They're doing lists like that. And then we are making one big list of every single one of those lists. So we have a list of lists of neurons, which is awkward to work with, but it should be fine. But with the way we're loading it, we are doing, we get how many lists we need. So we do like columns down like this. And then as we're loading them, we are finding how many neurons each list has. We'll do like 4 for the first one. And what I was doing before is I was loading all of these and then adding the actual information for neurons. What I tried to update that to without really thinking was to just do the first list and then do the links straight from it, but because these neurons don't actually exist yet, we can't do that because that is a null reference, which is just nothing connected to it. So that would crash the system if I tried to do that, which I did just try to do. I've noticed it and I corrected it. So I need to take this section from the saving. I need to put that into a new for loop, which is an exact copy of the previous for loop. It just changes the formatting. So it can actually load all of the columns before we start filling them in. So, linked neurons, we have to then take the next column and then, okay, hold on. So we are, if we're working on this neuron right here, what we need to do is we need to then jump to the next column, and this is going to have a whole load of the neurons loaded in already because of how I just changed the system. And then these each have an ID, so like 1, 2, 3. We probably would start at 0, but yeah. So this will say I have a link to neuron of ID 2 with a strength of 5. I was assume that this one is 0, this one is 1, this one is 2. So we then need to iterate across to the next list, and then iterate down that list until we get to this, which is confusing, but that will then work. So I have to like jump across 2 different lists to actually get to where the link is formed, and that's why we have the ID system. And that's just for saving and loading. So neuron.linked neurons dot link. Do we have the link function? Did I put that in this? Yeah, I got linked neuron. Okay. So the neuron must do. We don't access the linked neurons. We want to do the function link neuron, and then we want to pass a reference of the next neuron that we want. So to find that, we then have to okay, so we need the current ID. No, do we even need the ID? Do you need the ID? We need the layer number. Okay. I need to think about this. So we're currently here. We should know what layer we're on, but I don't think we're actually assigning that. Like we're doing neuron signal and neuron word, which noticeably isn't the layer. We actually don't care about the IDs that much. I don't think. Maybe we do. Where are we getting the ID from? We are doing it on here. So I don't think the ID actually has to be accurate to what the next one is. Do we? It does have to be accurate. Okay, that's a pain. Oh, I have to set the input. No, the God, I'm tired. Maybe we should just play the mole game. Maybe we should. But like every neuron has the layer and the ID number. The layer is how far across the list of lists they are, and then the ID is how far down the list they are. Not the list of lists, just the regular list. But I need to actually assign them that ID at some point. Which, I mean, Yeah, we do. We can do it when we are setting them up, but then we then only have access to that as we're actually setting it up, which might be fine. Because we already have the ID of the next one we're going to. So the next neuron doesn't actually need to know its ID. So this doesn't need to know its ID, but this one does. And I can then direct the rest of the code to where to find it based on the ID which the next one doesn't know. And then when we iterate through all of these, we will then just assign the integers as we go, which later on is then useful. But for this stage of it, even though we are using IDs, we don't actually need to know what they are yet. We'll just figure it out as we go, which it might be a terrible way of doing it, but it also might not be. So that's good enough for me. Okay, so we need the we'll do the integer within the start of the list. We're going to set that to 0. Int ID equals 0. And then, so for every time we start a new column, that then gets set to 0. Then we just set the first value to the ID of 0, set the second one to the ID of 1, you know? So each time we pass through it, we then do neuron.id equals ID. Easy. And then we do ID, which is this variable, increase that by 1. Then that will be accurate for the next one, and then it will again get reset for the next list. We probably ought to give it the layer tool, which will be we'll call it back here, so or declare it back here. So we'll do integer layer equals 0. Every time we go through a new layer, we're going to increase it by 1. We're going to do that right at the end. Although we could just call it -1 here and then increase by 1. I'll keep it like slightly cleaner with this being here. We'll start at -1. I'll do increase by 1 for each layer that we pass through, and then the neuron layer, we will tell it is equal to that layer we have just got. So it starts at -1, it immediately goes to 0, which is where we actually want to start. And then each time you pass through this, we're increasing by 1, so then just doing like 0, 1, 2. No? Which, I mean, there's probably better ways of doing it, but this should work. And I've been doing this for a while. How long have I been going? I've been going for 2 hours. So this should work, and for 2 hours of coding, this is pretty good coding for my brain. I'm gonna have to do like Duolingo after this. That's gonna be a pain. Anyway, so we have the ID, we have the layer number. We need to link the neuron. We know where we're aiming for because we have that in the save file. So we need to pull the information, the next number from the save file. Should we do that before? We should. Okay, so we'll do 1 here. We'll then handle the. Are we doing link or wait first? We're doing link first, right? Yeah, link. So we do the link, then we handle the getting the next input. We then handle the weight of that link, and we do need to do it again. We need to get the next data here. And then if the next data it's going to load is the marker saying that it is the end of the links, and it will start back up here, which none of these lines are affected by that input. And then it then grabs the next input for the next neuron. That should be good. Anyway, so the link, where are we getting the link from? We need the weight. I'll just do the weight first. Do neuron dot linked weights. We are gonna need an iterator probably. Yeah, we're gonna need an iterator. Okay. So before we start with the neuron, we need to make an iterator for both a reference to a neuron, which is this one, and a reference to an integer. I'll just copy paste that for the second. So for the list of neurons, we'll then make an iterator for that. We'll call it linked neurons iterator, and that will then be equal to the beginning of linked neurons. That should know what linked neurons is, but it doesn't because we need to get it from neuron dot linked neurons. Yeah, and I'll do the same one for this. So make this into an iterator, call it linked weights iterator, and that is equal to the neurons linked weights list from the beginning. So that's the iterator done. And then at the end of this, you want to advance both of them by 1. So advance this by 1. Duplicate and put this one in. And the weight is the dereferenced.
Said I left for an hour and still no mole.
Why do you guys love moles so much? And if we started moles now, in fact, did I do my Duolingo?
Helter _ said disappointed.
Okay. We could do moles. I mean, like, we're mostly done with this, I think. Actually, we're not. I still want to do the fire and the neurons. That's what, I mean, we could do moles. We could. I could just do like a really late stream. I don't know. I'll keep going with this for now. But if you complain loud enough, I might switch over. Like I'm like kind of in a stride here, you know.
Helter _ said pog moles.
Okay. I don't understand you guys sometimes. Like first it was the snails, now it's the moles. Like, everything I hate, you guys love. But we're definitely playing Turmoil tomorrow, which will have the moles in. I don't know if we're doing any of it tonight, so I do actually want to do this. But we'll definitely do moles tomorrow. Okay, so we are putting from the save file to the temperature to the temp input. I keep saying temp as temperature, which is really bad. This isn't being recognized for some reason because we don't have this one finished. So dereference linked weights iterator needs to be equal to the temperature to the temp int we just pulled from the save file here. That then should make this go blue again. Yes, it does. We need to do the link, which I mean I've been putting it off because I need to figure out how to do this. It's gonna be a little bit of a pain, but I mean it can't be that bad. We know Like, that's what we did the layer and the... I mean, only the layer really, but that's what we did that for. So we need... we could do one reference to it, like, way back here. So, I mean, we already know what layer it is, so I'll do... I'll do a iterator of the list of neurons. And then that will start... So this is neuron list iterator, and then this will start at the beginning of neurons. Dot begin. Why did it put a star there? Dot begin. Neurons dot begin. Why is this not working now? Neurons is a list of neurons. Why would that not work? No suitable conversion from list iterator. List. Okay, I've got no idea what that's saying. That's too many words for me. Too sleepy. Like, that should be fine. It's an iterator of the list of neurons, which is here. That's list neurons. Actually, yeah, okay, that might be a list of the list of neurons. I have a moss in my room. That's a big moss. Ah, that's huge. It's probably gonna die in my light later. It's already like flown inside of my ceiling light. That's probably gonna end up dead in there, which is very sad for it. It's definitely having a time. I think it just got stuck underneath my bed sheets. If I had a webcam, you guys would be going mad right now.
Helter_is said Mothpog.
Do I catch it? I mean, it's a big one. The small ones don't really cause like any trouble, but like a big one might actually start eating stuff, which my parents always complain about. It's never happened to me, but like, you know, I also need to fix a bug netting at some point. I've like neglected it for like a couple months. There's just got a big gap in it. I'm gonna go see if I can catch that moss in a mug real quick. You guys get to listen along, but this might be a little bit scuffed. The moss is like somewhere behind this fence. Nope, it's found its way down the back. There's a moss somewhere in the underworks of my room. Now, I do have my wardrobe like right there, so that's probably quite a bad thing. Also, don't know if you guys can even hear me from over here. Pretty sure you can.
Gene Drake 10 said moth.
And this mic is like surprisingly good at handling distance. It's definitely not cool. Where had the moss gone? I genuinely lost it. I saw it go down the back of my desk. I thought it would just get stuck there, but then like there's apparently a gap there, which kind of starting to expand in the works. It's gone down there. I could have led it anyway. Is that it? No, that's not it. Okay, well, I think the moss has just evaporated. So, I'll go back into my setup and see if it just shades up again later. Again, like, I've never had an issue with moss before. Like, my parents have had like a whole load of clothes eaten by moss. Like, they've got like all these complaints about it, and they're like laying eggs in their wardrobe kind of thing. But like, I've had so many moss in my room, and like literally none of my clothes have ever been eaten by moss. Like, I don't know what it is about my clothes and moss, but they just like refuse to eat it, you know? Anyway, where were we? What are we doing? we're finding the link, which we're getting by doing an iterator through the list of neurons, which this is going to start at the beginning, and then we are going to put it forwards by 1 right at the start. So this is always going to be slightly ahead of what we're actually on, which is, so advancing this by 1, and that is just going to be ahead, and that's going to be like, I'll bring creature up. So if we're on this one, then this one will always be on that one, and then when we move over to here, then this one will also move over to here, and I'll do that one instead. So that should just always give us the next list over. And from there we'll do a new iterator starting at the beginning of this. We will then iterate it by the ID number we have. And then that should tell us which neuron we're aiming at. Should. I'm not entirely certain. Also might have missed a couple of TTS in that time. You guys love the moss apparently. I'm not surprised, but okay. So we have the list we want, and then we'll do a
Cast Dragon 26 said Vadal Wave.
Hello Cast Dragon. Hey all. I'm doing code today. I don't usually do the code. It's not as popular as other oil rigging, but I wanted to do it, and so I am doing it.
Said hi Cast Dragon.
Yeah, I'm writing code for an AI. It's I mean, we're not teaching it anything yet. We're just doing the underlying structure, and then next time I work on this, which it's probably going to be offline because I both have no idea what I'm doing, and it's not as popular as the other stuff. So I'll probably do the second half of this offline.
Said hi, everyone.
We have
got done getting the green.
You got the green. Are you eating paper towels again, Cast Dragon? I know you like to do that. So we have the column. Now we just need the row. So we'll take neuron list iterator. From that we are dereferencing that.
Said Pog Green.
Or do you want to see what else is available? There's nothing else available. So we're dereferencing that. So that is now actually just a list. And we need to do an iterator of that. I'm not entirely sure what I'm doing on this one. I've confused myself by doing moss business. So we're making a list of neurons. It's going to be an iterator. We're going to call it neuron iterator, and that is going to equal the dereference neuron list iterator. So that's a list of neurons. That's a list of neurons. That should work. It's not happy about something. Don't know what it's not happy about. I need the dot begin. That's what I need. Dot begin. And now that should be happy. So this is now the start of the column, not that one. So we've gone across, now starting at the beginning of the column, we need to advance this by the ID number. If the ID, like for the first neuron, the ID will be 0, so there's no advancement, which I need to check if I've actually done on this. That starts at 0, we send the first one to 0, and then we iterate up, so yeah. We will advance this iterator by the temp int because that temp int is the ID of the connection. So advance, is a neuron list iterator. Oh yeah, neuron iterator. So advance neuron iterator by the temp integer. And then that should be the neuron we are aiming for. So we have now gone down by enough, and we are now at the target. So we just now need to set the neuron dot neuron dot linked neurons. Why do I do it over here? God, my brain is dead. It's getting the linked weights iterator from here. So we're gonna need this iterator probably. So linked neurons iterator. Dereferenced equals. God, I need to actually sit and think about this. So we are iterating through the list of the next neurons, which is, yeah, we're going to the one we want, which is going to give us a reference from the list. I don't think that's the same type of reference we'll get from the neuron, but it might work. So the dereference iterator, which is going to be the actual neuron's reference to the linked neurons memory address. God, I'm getting confused. We should be drilling right now. What is this? Oh my god. I'm gonna have to do Duolingo after this. Like, my brain already struggles with English, let alone other languages. It's gonna be painful. So this is just going to equal the neuron iterator. Will it take that? It will not. Remove that? No. Okay, I've confused myself. We'll just play around with the pointers and see if that gets us anything. But I think this is what I said. Like, the reference from the list is not going to be the same as the reference to the neuron. So I have to dereference the list iterator reference, and then I have to turn that back into a reference by getting the memory address, which you do by putting the AND sign at the front. So that is the that's the referenced version of the dereferenced version of the iterator of the list of neurons that is connected. No. The list of neurons that is from the list which is one ahead. And all that stuff. You know. My brain is at its limit. Okay, so that should now be done for the link there. So that should be good. That might be buggy because, I mean, you know what I'm sounding like at the minute. That's not gonna go well. So that's the link. That's the weight. I probably could have done that with this function. That is this. And that's for making a new link. This is the one I stole from my old code. I don't think we actually want this anymore. I don't think this even does what I want. This does neurons and a default weight of 1. I mean, maybe it'll be fine. I'll probably use it later. So I don't think we're using that for now, because all that does is adds a reference to the linked neuron and a associated weight with that, but we are already doing that manually through this. And like the amount of work it would take to like this function takes a neuron's memory address as the input for what neuron should be linked. But in order to get that memory address, we have to do all of this, which we don't really want to. Like, so if we're using that function, we'd still need to do all of this, and then we'd just be putting the output of that into the input of the other one. But that wouldn't set the weight for it properly, so we'd still have to do this, and we still have to pull the data, so we still need to do that one, and we still need to do that one. And we still need to do this. So, I mean, that function is literally useless to us right now. So I don't need that. So that should be... is that everything? Is that the loading done? I think so. Probably riddled with bugs. This is the loading data. I do now realize I'm probably not doing memory management properly. Like, I learned to code in Unity, the game engine, in C#. Meaning I have like no awareness of memory management. Like what I did on my first attempt, like, what was it, like a year ago? What I did is I literally just... God, we don't need all of that. Where's the loading? There it is. So I did my load data, I loaded all the like standard data, like what we've got on this one. We are loading the size of the list of lists, and for each of the lists within that list, we are then resizing all of those. So that would be the same as the beginning of this. And then this loaded, I think it was every individual neuron one by one, and it opened all of those in a new function. And what would happen is it would load the neuron once. In fact, yeah, it load the neuron once, and then it goes through all of this with terrible memory management. Then once it hits the end of this function, and everything done within the function can then, like, it's no longer needed because the function is over. And so that then gets collected by the trash collector, whatever it's called. Garbage collector, I think it's called. I don't know. But then that would clear up all the memory leaks from this. And then this one would just start it again on the next neuron. And then this would leak a whole load of new memory. But then it gets reset. So that's like a terrible way of doing it. So on this one, I probably ought to figure out how to actually manage the memory. It's probably about time I do that. So I'll probably end up asking my dad. He's been working, like, he's been in software for like 30 years now, something like that. So he's gonna know how to actually manage the memory. So maybe I will actually show this to my dad and ask him where I'm going wrong. Because like on the previous attempt, it was like atrociously bad. Like this would load about 1,000 neurons, and then it would just like grind to a halt and then crash from running out of memory, which is really bad. So I probably ought to fix that. It's actually like really funny in the early times because it was like very slowly slow down because it's like losing memory every time. Like the first like 400 or so would go absolutely perfectly, and like after that it just got like slower and slower. Like every time it's like gradually running out of more and more memory. Okay, until it just like gave up and couldn't find anymore, and then it crashed. Anyway, so we've got loading. That should be fine. Then we need to handle the firing neurons, or we can make the dummy save file to get it started. Because at the moment it doesn't have a save file, and I haven't told it what to do if it doesn't have any neurons. So it tries to load. It loads literally nothing, and then tries to run with no data. It doesn't know what to do and immediately crashes. So maybe I'll make the dummy save file to get it started. I could also just make it so that it doesn't crash when it doesn't have data, but like, you know, if it doesn't have data in it, I don't really want it to run anyway, so like, if it's crashing because of that, like, by that point it's already gone wrong, you know? It can't get any worse, so I might genuinely just leave that. Anyway, so we're gonna fire the neurons now. Or at least do the back end for how it works. So what we're doing for firing the neurons, we'll get our handy, maybe I'll do a new list. Making a bit of a mess, we'll do a new list over here. So we have our neurons. I do 3 layers, including input and output. So what we're doing is, the input goes in, it selects some neurons to get fired. I do those 2. And what this new bit of code is going to do, is it goes to the first column, and then it checks all of these individually. Does this need to be fired? Yes it does, so it then sends a signal out to the next ones. Does this one need to be fired? Nope, it doesn't do anything. Does this one? Yes, it does the signals, and so forth. So it goes down the list like this, checking every individual neuron to see whether it has the activation energy to activate. If it does, it then sends its signal to the next group of neurons to then give them the activation energy. And then this will then start getting to the next list, and it'll be like, does this have enough activation energy? Yes it does. Activate it, send the signal out. Is this one? Nope. Is this one? Nope. Does this one? Yes. Send the signal out. And so forth. It's just going down each column like that. Because none of the columns can affect each other vertically. And this is also where the GPU processing would come in. Because at the moment we're going to get our CPU core to check all of these one by one. What the GPU would do is you could get it to do every single one of these neurons on a different core. Do I still have the picture I drew? No, I didn't. But the GPU has like tens or even hundreds of thousands of cores. And you can just assign every neuron to one of those cores. And you'll basically never run out. It's why GPUs are so sought after in the AI software stuff. But because we're coding real simple at the moment, we are just going to use the CPU. I'm going to get one CPU core to check every single possible neuron in the column. But again, because they don't affect each other horizontally, you can do all of these in any order. As long as they all get processed once, then the signals to the next column will be accurate. That's what we're going to do. We're going to go through each list, we're going to check them all, see if they have the activation energy. If they do, we'll fire them, which we already have the code for up here. That is written today, so I know it should be compatible. I'm not going to say it's 100% going to work, but I'm confident enough to try it. So, this should be fairly simple. We will do an iterator of the list of lists. So list, neuron, and those two. You then turn this into an iterator. This is, what do I even call this? What did I call it last time? It's neuron list iterator. Neuron list iterator. I did that with a capital N. I shouldn't do that. I use camel case, or at least I try to. I've done one of the neuron names capitalized. I think it's neurons plural I did, which I probably ought to go back and fix. Yeah, that one. So that is a variable I'm using, but it has a capital N, which I really shouldn't have. Alright, so we're doing that. We are setting the iterator equal to the beginning. Laptop got funky. What song is this? Did this autoplay? It did, but it's fine. So neurons dot start for the start of the list of lists. This is unhappy about something. Do I want capital? No, it's dot begin, not dot start. Okay. So we got the beginning of the list of columns, and then we don't even want the iterator for that. No, we just want for list of neurons. Why list of neuron? We'll call this neuron list in neurons. There we go, that's slightly better. So this will then check the neurons list of lists. And then for every list of neurons in that, it will then do this loop once, and neuron list will be that relevant list. So for that column, we will then go through another for loop. So for every neuron, we're going to call it neuron. For every neuron, which we're calling neuron in the neuron list, we will then check if it has enough activation energy, which I think I had a variable for that. We have required energy, so if neuron dot activation energy is greater than the required energy to fire, then we will take that neuron and we will fire it. And I think that's just done. Like, we're going through the columns there. We go through every column, and for every column we go through every row. Row, that's a word. Then for every neuron, we then see if it's supposed to fire. If it is, we fire it. Like, that's. I thought this would be like another one like this sort of size. Well, maybe not that. Maybe more of this size. But yeah, I think that's literally just done. I'll put the comment at the top. We don't actually need it, but like, we really don't need it. I'm not. That's like, I can get that, but just reading it was like no issues. Like, I think that is just done. Okay. I mean, we might be done with coding at this point. We don't have the dummy save file to get started. We of course also don't have any learning capabilities, which I'm gonna do another time because that's too much to do today. I also don't really know what I'm doing for it, but like, I think this should be good. I mean, we'll run it just if it crashes. Again, it doesn't have any data now, but it probably will crash. It's going to search for the savefile.txt. Load data, identify not found. Oh, we do actually have a couple of errors. Okay. So load data, identify not found. That's going from there to here. This is what I said. This save file just doesn't exist. So we will create that save file. I'm pretty sure I called this one AI test 2. You have one called data file, which is just a test. We don't care about that. That was from an older test. Actually, I'll leave it in there. Like, for some reason I couldn't get Visual Studio running, so I just took an old failed project. I just commented out at the bottom. So that's what that was using. This is this was part of this attempt. I started it. It wasn't working out, and so I decided to start over to figure out what's wrong with it. So this is an attempt where I started over. But then, like, in the process of starting over, I then finally figured out what was wrong, and then went back to this one and then I fixed it. So this is completely redundant, but as part of an old attempt. That's not even its own attempt, it's just part of the other one. Okay, so load data couldn't be found because we don't have a save file yet. Put the save file in. I'll leave the data file for now, even though it's not needed. So that should take care of that error. There are still the other two errors we need to deal with issues between integers and floats, apparently. Still not getting the identifier, apparently. We'll check that in a second. So, this is trying to add a float and an int. The activation energy is an integer, the signal is a float. Possible loss of data? And that should run without it, but oh, we'll just call this a float, because I might do mass on the activation energy later, so that should maybe take care of both of those warnings. Hopefully. No, it didn't. I only got one of them. So this is trying to convert an int to a float 2. This is neon.signal equals temp int. Temp int is of course a integer. The neon signal, I'm assuming, is a float. Yes, it is. We could just call this a float, you know. Although I actually probably shouldn't. Fuck. We're gonna call both of these hits. Oh, that's the worst possible way to fix it. But I'm very lazy. That should now mean both of these are ints, which is a terrible, terrible solution. Like, do not learn from me, chat. Like, everything I'm doing, don't do it. So that takes care of both the warnings. We still have the identifier not found. Oh, yeah, I got it. So this is being compiled, like, the main function is being compiled before the load data function, because the load data function is literally just further down in the list. That's what that's meaning. So we can either move main to be below the load data, which is a very valid option. I don't think this actually uses anything else, so I could change the order and just like not do anything else, but you know, we're not going to do that. So we'll declare a function called load data. We want a void to actually say it's a function. And we are declaring it, meaning that it can now use it as an identifier. Yeah. But because so it will compile this properly now, and this is empty, and then when we set it up down here, because it's the exact same name, this one will then override what we wrote in before, which was literally nothing. So we have a nothing piece of code here which is being referenced to, and then we are replacing the nothing code with what we actually want. And with that, I think we're doing Duolingo. I could do the dummy save file, but my brain is kind of dead right now, so. And it does run, or it at least compiles. Again, it doesn't have any data, so it will have... That's not taking inputs. Why is that not taking inputs? Oh. Oh, okay, I see. Again, because we don't have any actual save file, my leg is going numb. It's then going through this, I believe? Maybe not. But somewhere in this it has found an infinite loop, which of course isn't particularly good, but I mean, I'm pretty sure that's just going to be because it doesn't have data to use. Anyway, I'm happy leaving it there. Actually running it would require a dummy save file, which I'd have to make manually. I have to do the formatting myself, which would probably take half an hour, which, yeah. So I'm gonna leave the code there. I'll probably do the learning part of the code off stream, because again, it's not as popular. Although I might just do an unscheduled stream at some point, just so I can like do it. But anyway, now we're gonna do some Duolingo. I'm gonna rename the title. So instead of learning AI, we're now learning JP, and we're gonna be in the Duolingo category. There you go. If people do want to see the rest of the coding, let me know and I will stream it. If not, there's a 50-50 on whether it'll get streamed. I do need to do some research on how to actually most effectively teach it, because like I have taught AIs before, but not particularly well. There's probably like a better way for me to do it. Anyway, we're gonna learn Japanese now. It is Japanese time. And tomorrow we'll go back to Knowledge. And where's my Firefox? We'll get Duolingo website up, and then I will show you guys Duolingo. I use the Krita source, which I really shouldn't use because it's like actually labeled as Krita, and it was like assigned to Krita. Oh, I have been congratulated by Danette for completing my 14-day streak. Huge moment. Anyway, so where we ended that last time is I'd already done half of the time stuff when I last ended Duolingo, when I last used it. Like, this was the last thing I did before I dropped it. I dropped it because I was doing it on my phone and it only had a light mode back then, meaning my eyes were like genuinely hurting and giving me headaches. But this was the last thing I did before I dropped it. So I knew half of it, and that was enough to skip ahead to Unit 10. For those who don't know, I started this either like beginning of Unit 3 or beginning of Unit 2. And I've not gotten more than... I don't think I've actually reached Lesson 2 out of any of these before skipping ahead to the next unit, which is of course terrible for learning because I'm not doing any drilling or practice or anything like that. I'm just skipping ahead at literally every option to do it, which I really ought to go back and like practice stuff, but you know, like we have to choose between going back and practicing or pushing forwards and skipping through even more modules, so naturally we're gonna skip ahead on everything. This is a new module, so it's gonna have new words. I'm not going to name most of these, but I'm probably not gonna know like at least half of them. But we'll learn. So this is Kukoi?
空港
Kuko. Okay.
地下鉄はここで
So
す
it's a little bit quiet. So I'm gonna turn the music down. This I don't know whether that's free or not. I'll go back to this one. So I'll turn this down and I'll turn Firefox up. That's gonna be a little bit down. I'll go to the volume mixer and turn Firefox up for this.
地下鉄はここです
So
地下鉄
Shikatetsu is not one that I know, it's a new word. It is a subway.
地下鉄
Shikatetsu. So it's subway, where is, Koko is here, des makes it a statement, so the subway is here.
空港はどこですか
Kukoi,
空港
where,
Wa.
what was the word there?
空港はどこですか
Doko. Doko is where,
どこ
desu
です
ka
か
turns it into a question, whereas des by itself is a statement. So this is airport is where question. Easy. Airport. Kui Kukoi. We need to do it this way around. Like the letters on this, can I actually show you? Like they have the markings for whether they're the start of a word, or the middle, or the end. So that's helpful. But for this one, I had two U's. I put the end one on before the middle one, which messed it up. Anyway, so koi koi or ku ko, and this is ku, this is ko. I'm not entirely sure what it makes with the U sound at the end, but we're here to learn. I have another moss in my room, but it's a small one. I'll probably smush that if it gets too close.
地下鉄じゃないです。
Shikatetsu is subway. G is like usually hour, like
じゃないです。
Jainai des. Okay, this is all of
Janai desu.
this.
地下鉄じゃないです。
Huh. I'm not sure how it's getting all of that. So Nai is not like you can see that like where it like roughly splits up into the individual parts. So Nai is not, have not, do not. Without the I on the end, it can be do not, or name, or an adjective ending, apparently. Des is a statement, so it's something
じゃないで
statement,
す。
something not statement.
じゃないです。
I don't know
じゃ
whether
ないです。
I don't know where the start of that comes from.
じゃないです。
Jai. I don't know where Jai. That's confusing me. So, so
地下鉄
subway
じゃない
is
です。
not.
地下鉄じゃないです。
It's not a subway. Shunai desu. Kasetsu.
地下鉄
Shikatetsu. Shikatetsu. With a TSU on the U shape. Tetsu. I don't do the second S in that. Tetsu? And that sound like it's Tetsu. But it's Tetsu. I don't know. It's not a subway. Oh, okay. 5 in a row. Subway is where's it? This one? I'm getting confused with airport. Airport is Kuso? But airport, maybe? I know. Subway, I've already forgotten. We got Tetsu, but I don't remember whether that's part of the subway. I don't know this. Tetsu. Shikatetsu?
Te.
Oh. Shikatetsu. Maybe. Yes, okay. Shikatetsu. I should have been better at that. I should have been better. Because we literally just did it. Shikatetsu for Subway. Subway is Shikatetsu.
地下鉄
Two is Ni. Kukoi is
空
airport.
港
Hotel is Hoteru.
ホテル
This one is Soko,
そこ
which is there.
駅はそこじゃないです
Eki wa... Wait.
駅はそこじゃないです
Eke wa soju... What? Hold on. Eke...
駅
Eki wa...
は駅はそこじゃないです
Soko is
Soko.
there. Shinai desu.
じゃないです
This is not. So, Iki, which I don't know what that is there not. So something is not there. The train station isn't there. Ike. I'm pretty sure we have seen that before, but I didn't remember it. Iki, yeah. Because this one is shaped like a key. And there's like 4 different ones which look like this, and I always mix them up. But this one is key, because Tree told me.
すみません、地下鉄はどこですか？
Excuse me from the Sumimasen.
すみません、地下鉄はどこですか？
Shikatetsu is the subway. Where is Doko is where. Deska is a question. So excuse me, where's the subway? Shikatetsu.
バス停はここじゃないです。
Faster. Baster is bus stop. I remember that now. That took me a second, but Baster is bus stop. It's probably this one.
ブラジル
That's Brazil. Okay.
バス停
Baster. It's a bus stop.
バス停はここじゃないです。
Bus stop Waffle is Koko is
Koko.
here. Shinai desu
Janai
is
desu.
not. So the bus stop is not here. The bus stop isn't here. Okay. Where's the subway? So subway wa doko desu ka? Subway is this one, which is Shikatetsu.
地下鉄
Yeah, Shikatetsu. Waffle
Wa.
is Doko for
Doko.
where. Desu
Desu
ka
ka.
for question. Train station is where question.
すみません、空港はどこですか？
So excuse me from the Sumimasen. Kukoi is the airport. Yeah, airport. Waffle is Doko for where. Deska for a statement. So, where's the airport? Excuse me. Airport is where question, which translates to excuse me, where's the airport? Bus stop is Basta.
バス停
Airport is Kukoi.
空港
Cool is Kakoi.
かっこいい
Big is Oshi, which I probably
大
wouldn't have.
きい
Oki. That's the key shaped one. Tree told me that I should have remembered. And 3 is San.
3
Okay, the airport is there. We don't have to care about the so it's just airport is there. There is Soko. Airport is Koiko. So airport
空港
is
は
there.
そこ
Statement.
です。
Airport is their statement.
駅はここじゃないです。
Eki, we had this before. That's train station. I did see these, so I slightly processed that. I saw the station. I didn't see the train. So train station is from the where. Koko is here. Shonaides is not. So the train station isn't here. Train station is here. Statement, but not. No. And the subway isn't there. Soko is there. Subway is Shikatetsu. So it's subway
地下鉄
is
What?
there.
そこ
I need to work on what they will sound like. Like half the time I get it, half the time I don't. What is this?
じゃないです。
Genaides. This little Y is a yeah sound. This is a j. So jai. And this is na. This is I. Genai. And then des on these two. De su. This is the same su from sushi. So subway is the not. Okay. Ichi is 1. Hoteru is hotel. Yeah,
ホテル
Shikatetsu is
地
subway.
下鉄
Bus stop is
バ
Buster.
ス停
Small is not one I've done that much of, so this is key. God, it's got 2 of these. I'm pretty sure that one's key. I'll check the sound.
小さい
Chisai. Okay, I didn't get either of them. Chisa. With an extra I on both. Chisai. As lesson done for the streak. I do actually need sleep. My sleep has been really bad for the last couple of days. So, even though I probably should stay around for longer, that's an
Get more
so, like, I probably should go for longer, but I think I am going to call it quits, just because I have been behind on my sleep recently. We've got the streak, so I'm gonna go to bed. Yeah. Thank you for watching. I will. Oh, you're actually still seeing the shrimp slightly behind the behind that. Whoops. I always forget to hide that. I will be back in 9 hours, almost exactly, for the morning show. After that,
Cast Dragon 26 said
Bye bye,
they will
Cast
wave.
bye bye, Cast Dragon. After morning show, the next one.
Hell to
Tomorrow-
underscore is said by Ed.
Tomorrow is Tuesday, I guess today for me now. So I'll do the afternoon show, but no evening show. I might still do an evening show. It depends what I feel like, but it's not scheduled, so don't expect it. But yeah, I'm going to bed now. Super chat. Me go sleepy. Bye bye. Thank you for watching. Adios. I don't know how to say goodbye in Japan. I almost said sumimasen, which is excuse me. I guess it would still kind of work, but see ya. Bye bye. I'm halfway brushing my teeth. I forgot to raid. I don't know if there's still people here. My mouse is for the teeth, please. Yeah. Thank you, Helter. I was gonna do that. I don't know, you can see my desktop. Like, I was actually typing it out. But I couldn't remember how to spell it. Ah, God. Okay. Thank you, Helter. Thank you.
Cast Dragon 26 said so doesn't one good.